Okay, so in this video, we want to give an example of the chain rule of differentiation that contains a small twist, so we have to be here a little bit more careful than usual. So again, clearly the power of 5 is the outside function, right? We have to evaluate this first and then raise the whole thing to the power of 5. And again, the chain rule always says that we differentiate when we have compositions of functions, always first the outside function. So by the power rule, we bring down the exponent, we subtract 1 from the exponent, and the argument of the new function is always the original argument. Therefore, x squared minus 1 cubed minus x squared. But of course we're not done. This only takes care of the derivative of the outside function, the power 5 function. So this peels off the outer layer of our function, but we are still left with the second layer, the initial argument. And so by the chain rule, we have to multiply whatever we have from the first derivative by now the derivative of what's left over, the inner function. And here we have to be careful. We have a difference of two functions. So we will have the derivative of the first minus the derivative of the second. And all of this derivative must multiply the initial function. So we have to here open up a pair of parentheses. So we have to take the derivative now of this function. And again we have a chain rule. We have the initial polynomial, x squared minus 1, but then raised to the power of 3. So the power of 3 here is the outside function. We apply the power rule first, bring down the exponent, subtract 1 squared, and of course of what? Of its initial argument, x squared minus 1. And here's where you have to be careful. We are not ready yet to jump to minus the derivative of x squared. This is not the full derivative of this function. This only takes care of the outer layer, the power 3. There is a second step here in our chain rule, times the derivative of the inner function, because now we've just peeled off the outer function, so we're left with x squared minus 1, so times the derivative of this, which is 2x. This peels off the second layer, and now that this layer and this one have been peeled off, there's nothing left. So this is now the full derivative of this first piece. Now we can move on to the derivative of the second piece. This one is of course trivial by the power rule, minus 2x. And this completes our derivative. And you can see there's a whole lot that has to be multiplied by the first term. So these two brackets were crucial. Without the parentheses, then the negative 2x would not be multiplying the initial function, which would be a mistake. We can simplify now just a little bit further. If we factor the common multiple of 2x, combine the 2 with the 5, which will give us 10x, times, of course, what's left over. So here, taking away the 2x, we're left with 3 times x squared minus 1 squared. And then here, taking away 2x, minus 1. And we'll leave our final answer just like this.